Welcome to Homework Lib.
So in this question, we have sodium chloride, and we want to model it as an electric dipole. So in part A, we know that we assume that the two atoms are separated by 0.24 nanometer. And if we assume that they just have plus E and minus E, and we want to know what is the amount of dipole that is given by this model. If you review chapter 21, you'll see that the equation for dipole P equals Q times D. Q is the charge of each atom, and D is the distance between them. So in this case, Q is just E, is 1.6 times 10 to the negative 19 coulomb, and D is a distance, it's 0.24 times 10 to the negative 9 meter. The amount of dipole that is given is 3.8 times 10 to the negative 29 coulomb meter. So that is part A. And then for part B, what happens is that we are given a dipole. We're told this dipole is 3.0 times 10 to the negative 29, and then we are saying that we assume we do not know the charge of each atom. If we know that it's a dipole and we know they are still separated by 0.24 nanometer, what will be the charge of each atom? So we're just using this equation backwards. Now we are trying to find what Q is. Q is dipole moment over distance. So it's 3.0 times 10 to the negative 29 coulomb per meter over 0.24 times 10 to the negative 9 meter. This gives us 1.3 times 10 to the negative 19 coulomb. So we see now that the charge given this dipole moment is a little bit smaller than 1 electron. And then for part C, it asks us how much is this charge? What is a fraction of the electron? Well, that's just a division. We divide this charge by the charge carried by an electron. And it's just 1.6 times 10 to the 19 over the charge carried by an electron is 1.6. 1.3 over 1.6 is roughly equal to 0.81. That is a fractional charge. All right, and then now what happens for part D is that the equilibrium distance between a different atom, between hydrogen iodide, is 0.16 nanometer. And we know that the measured dipole is 1.5 times 10 to the negative 30 coulometer. So what is a charge and what is a fractional charge? So we will repeat our question 2, but for a different type of molecule. Now the charge is P over D. Let me try this is for hydrogen ion, hydrogen ion, hydrogen ion. It's 1.5 times 10 to the negative 30 coulomb meter over 0.16 nanometer. 0.16 nanometer. And this is 9.37 times 10 to the negative 21 coulomb. Finally, we want to find what is a fraction. So 9.37 times 10 to the negative 21 coulomb over an electron is 1.6 times 10 to the negative 19 coulomb is 0.058. So the fractional electron charge is only around 0.06. So these are part 1 to D. And then the question asks us to discuss the result because why does this answers differ so much from part C? Well, for part C, we have sodium and chloride, and they have a pretty large fractional charge, but here for hydrogen iodide, we only have a very, very small fractional charge. So this tells us that this bond is a lot weaker, and that is to be expected because we know both sodium and chloride, they are ions, they are very strong ions, and whatever bonds them together, it's an ionic bond, as opposed to um, hydrogen iodide. It's not we know it's not an ionic bond, it is a covalent bond because usually hydrogen doesn't form metallic ionic bonds with other things. So why are the answers so different? Because they form two different types of bond, and the bond between hydrogen iodide is a lot weaker compared to sodium chloride.